Triangulum is a 3-qubit desktop quantum computer, which is only slightly larger than a normal computer and weighs 40 kilograms. With the software SPINQ Triangulum can use for quantum computing education and self-defined quantum algorithm computing very well. The software used for Triangulum is work on the Windows system. It should be installed on a PC or laptop. This is the software of the Triangulum. It currently supports 2 languages, Chinese and English. The whole system has 6 functions: quantum computing, NMA, user management, task management, calibration, and knowledge. The interface of quantum computing has 4 areas: operation area, result area, information area, sample structure model. There are single-qubit computing and 3-qubit computing in the Triangulum. In the operation area, we have defined some quantum gates in the system, including single-qubit gates and multi-qubit gates. You can click the Help button on the right to view the definition of each gate. The 3-qubit computing has built-in 18 algorithms, for example, and users can directly choose and run the experiments. To create quantum circuits, we can directly drag quantum gates to quantum circuits. After we build the quantum circuit, if we want to save this circuit, we can click Export to save it as a .txt file. And we can also click Import to import a quantum circuit. Besides, if we want to move all the gates out of the circuits, we can click Clear to delete all gates on the quantum circuit. Before running the experiment, you can name the current experiment at the task name on the left. When we are ready to run the quantum experiment, click Run to start the task, or click Simulate if you only need to simulate. After clicking the Run button, the progress bar at the upper left will display the current experimental progress. Click Progress, and a progress window will pop up, where you can view information such as progress, signals, and parameters. The whole experiment will take about 55 seconds, and the results will be displayed below after the experiment is completed. The light blue bar is the simulation result. The dark blue bar is the experimental result. And the value will be displayed when the mouse is moved to the bar. The lower left shows the molecular structure of the sample trifluoroiodoethylene placed inside the instrument, which uses the fluorine atom as a qubit. This is the quantum computing function in Triangulum. The nuclear magnetic resonance function. In nuclear magnetic resonance, we can define the pulses and emitted to perform related physical experiments. We can define the phase, amplitude, and width of the pulse. Then click Emit. The system will display the NMA signal. We provide the pulse according to the quantum gate in quantum computing. Click Import, and select the pulse file according to your requirement. Check the pulse file on the right. Send the pulse, and the system will feed back the read nuclear magnetic signal. We can also perform Rabi oscillation experiments under the NMA function. When the Rabi oscillation experiment finish, the spectrum and data will show in the bottom. We have made secondary software on the basis of the main software. The secondary software can be connected to the main software through LAN. so as to indirectly use the Triangulum to perform quantum computing tasks. The secondary software only has one function, quantum computing. On the main software, we create and manage secondary software accounts through the user management function. We can click Create to create a new secondary software account. Or view the status and detailed information of the existing account. Or delete the account. In the secondary software, when we confirm the LAN connection is successful, we can sign in with the account. This is the function of the secondary software and user management. Task management is the function for task recording and management. Under the Current tab, you can see the current and upcoming quantum computing tasks. If multiple secondary software submits quantum computing tasks, the order of the tasks will be given in here. Under the End tab, you can see the completed experiments. We can find the experimental task we want to view according to the name. And view its circuit and results. We can also rerun the experiment. Calibration is mostly used by engineers to calibrate the instrument. For the user, here we need to care about the temperature of the magnet. There is a temperature control system in the Triangulum, which will automatically control the temperature of the magnet around 35 degrees. Before we do everything, please make sure that the temperature of the magnet has stabilized around 35 degrees. Triangulum provides some basic quantum knowledge and NMA knowledge to learning, including quantum computing. Basic NMA knowledge. In addition, we also have a complete quantum computing experiment courses. Each lesson will show the theory of algorithm and the whole process of real machine experiment in detail. It will help students understand the course content and machine operation better than others.